So in this question, we're given two graphs. The graph on the left here is f of x. The graph on the right here is g of x. And we're told that g is a transformation of f of x. And more specifically, where g of x is a times f of bx. And so this tells us that g is a transformation only of vertical stretches, that's the a here, and horizontal stretches or compressions, which is the b here, and we're trying to figure out what those values would need to be. So no shifts, just stretches. So to start with this, let's think about how stretches change the function. So if we have a vertical stretch, that's going to change the outputs or the y values of the function, whereas a horizontal stretch or compression is going to change the x values or inputs of the function. So here, if we look at the inputs to the function, so let's start with horizontal. If we look at the inputs to the function, here we see we have values ranging from 1 to 3. And over in our second graph, we also have values ranging from 1 to 3. So it really looks like the input values are not changing. So they have not been stretched out larger or compressed smaller. They haven't been flipped over to negative x values. It looks like the x values are staying exactly the same, right? The inputs are not being stretched or compressed. And so that would suggest that this value of b here must be 1. In other words, we're not stretching or compressing. We really just have f of 1x or f of x here, no horizontal stretch or compression. All right, so then if we look at our y values, we can see that these graphs definitely look different. The first thing we'll notice is that this first graph is sort of a wedge pointing upwards, and the second one is a wedge pointing downwards. And that's a good indication that we have a vertical flip, which means almost certainly this value for a, in this case at least, is going to be negative. But now let's look at the actual values. Here, at our first point, you'll notice that the output was -1. If we look at the corresponding point in the second graph, you'll see it's now at +2. So how do we get from -1 to +2 using a stretch or a multiplication? Because remember, this is multiplying a times the function here. Well, to get from -1 to +2, we would have to multiply by -2. Now let's see if that works for the other values. So here, the original y value is 2. The corresponding point on the second graph is at -4. And so yes, if I take 2 and multiply it by our -2 here, we would also get the -4 we're seeing here. Likewise here, when x is 3, the original y value is -2. Multiply that by -2, and we get the value here, which is a y value of 4. So we come up with a is -2, and because there's not any horizontal stretch or compression, we find out that b is 1. All right, now let's look at a similar question where we have, again, a graph on the left, which we're calling f, and a graph on the right we're calling g, where again, g is a transformation of f, and where it is a combination of vertical and horizontal stretches or compressions. So let's again look at the x values and the y values, the domain and the range, if you will, to see what's changed. So here, the original domain goes from -1 to 2. Again, that's in the x's that we're talking about here. And in our new graph, the domain goes from -6 to 3. And so that's definitely different, so we definitely have something interesting going on the horizontal here. For the outputs, the original graph goes from a y value of -2 at the bottom to a y value of 1 at the top. The transformed graph also goes from -2 at the bottom to 1 at the top. So it doesn't look like the y values, the range, has expanded like a stretch or contracted like a compression. So because the range is the same, that's a good indication here that the vertical stretch or compression factor is just 1. There is no vertical stretch or compression. We just have 1 f of bx or just f of bx. Okay, so now let's look at the horizontal. So the first thing you might notice is that the higher arm of this little V shape here, the higher arm was on the right in the original graph and on the left in the second graph. And that's a good indication that we have a horizontal flip going on here. But remember, really what we want to look at is what are we multiplying the x values by? So here I have my x value of 0. I multiply that by anything, I get 0. So that point's not going to change anywhere. Here I have a point where x equals -1. And the y value is also -1. So I'm looking for this point that has the same y value. It's this point over here. But now you'll notice that the x value is 3. So how do I get from -1 to 3? I would multiply the x values by 3, right? So I'm going to multiply the x by 3, we're saying. Right? So we're going to multiply the x by 3. Sorry, by -3, more specifically. So let's make sure that that works for this other point. Here I've got the point 2, 1. It corresponds with this point here at -6, 1. And indeed, if I multiply that x value of 2 by -3, I end up with an x value of -6. So I'm multiplying my x values by -3. But remember, horizontal transformations don't just use this number that we're multiplying x by. The horizontal transformations kind of work backwards of what we would expect. And so for a horizontal stretch or compression, in order to multiply the x values by -3, my compression factor here, or stretch factor, would have to be -1/3 the reciprocal. Remember, this one is always the reciprocal of what I multiply the x values by. So in this case, a is 1, because I'm not having any vertical stretch or compression. And my b value here is -1/3. In order to... Remember, it's the reciprocal of what I multiply my x values by. So because I'm multiplying my x values by -3, my b value, my horizontal stretch or compression factor here, is -1/3.